Hello, today we are doing Unit 4A, Mission 2b. We are continuing to solve proportions. We're just doing with shapes today, looking at similar figures. What are similar figures? They are the exact same thing, the same shape, but they are different sized. Different size. So those are the first two things. One word that relates both of these is something's the same size but a different shape. We call it proportional. I can't spell, proportional. So that means, proportional means we have the same ratio between our two objects, they're just different sizes. So here are some examples of things that are not proportional. These triangles are definitely not proportional. They're not even the same shape. They're different sizes, but they're not the same shape. This one is clearly way taller than this one compared to the bases. Here we have the same object, but it's not the same size. It's not even the same shape. This one is kind of squished. That is not proportional, okay? So they have to be the exact same shape, just different sizes, one bigger and one smaller. So let's look at a couple of examples here. It says write the ratio of the corresponding side lengths. Set up a proportion to solve for x. So we need to figure out this side. Well, which side is on the same, or which length is on the same side as the bottom on this triangle? Well, it would be the bottom on this triangle. So if I set up a proportion from the big triangle to the small triangle, I would write, well, x is on the big triangle and 21 is on the small triangle. So that's my first proportion, this side to that side. And I know two of the other sides. I don't know why, so I don't want to use this side because we don't know what that side is, but I can use this side here. Those are proportional, or we can write a ratio from the big triangle to the small triangle. So the big triangle's side length is 16, the small triangle's side length is 12. So we set up a proportion, and now we can cross multiply. Multiply these and set it equal to multiply those. So 21 times 16, 21 times 16 on one side equal to 12x on the other, 12 times x. So I would plug in my calculator, 21 times 16 to get 336. So I'm going to write that in here. 336 equal to 12x. Then the opposite of multiply would be divide, so we could divide both sides by 12. And we would get 28 equal to x. X is 28. Which makes sense that it's larger than the small triangle, which has a side length of 21. It didn't technically say to solve it, it just said to set one up. And we did that. Next, it says error identification, which tells us that there is an error in the proportion that they set up. We need to find the error. Identify means to find it, and write the correct proportion. So here, if I look at this number 1, that goes with our small triangle, and 12 goes with our big triangle. However, those two sides are not the same on both triangles. See how this one is the short side? It should be set up with this one on the short side. From this small triangle to this big triangle, those two sides are proportional. They're the same side of each triangle. So this 12 should not be there. Over here we have 4 from the small triangle, and it's matching up with 3 on the large triangle. So these two, 3 is on the big triangle, but we have some things going super wonky on this, super crazy. So if we're looking at the two sides that they have picked out here using those same numbers, from the small triangle to the big triangle, our proportion from small to big, we would have 1 over 3 is equal to, from the small one, 4 over 12. So what they really had was these two numbers flip-flopped. 1 over 3 is proportional to 4 over 12. It's the same size triangle, just this one was really just multiplied by 4. It's 4 times bigger than that one. Let's flip over to the back side and we're going to write some proportions. So this is where it maybe will come all together for you, make more sense. It says find the unknown side length. We have the small picture and the big picture. It's the same picture, just different sizes. So I'm going to set up my proportion from the small picture to the large picture. I'm just going to abbreviate those. And if I'm looking at the height on this picture, I need to look at the height on this picture. I'm going to use x to represent that height. So the small one is 4, the large one is x, we don't know. And the length, if the small one is 6, the large one is 17. So we can set up a proportion, which we did, and cross multiply. 6 times x is 6x. 4 times 17, that's one I maybe don't know in my head. 4 multiplied by 17 is 68. So we have 6x equal to 68. And then the opposite of multiplying by 6 is dividing by 6. So 68 divided by 6 is 11.3 repeating. Which when we get to fractions later, that is going to be 1/3. 0.3 repeating is 1/3. So x is 11.3. Alright, next one, we have the exact same shape. One is smaller and one is larger. So when I set up my proportion, I'm going to start with the small one and move to the large one. LG is large, SM is small. Notice though that the figure is turned. I have this highlighted here. This is the shortest side on this shape, this is the shortest side on this shape. So it's really turned, kind of rotated, and it is smaller as well. So this side, 15, goes with this side, 4, and then x here goes with 6 here. So we are going to look at the blue and the green that I have highlighted. From small to large, we have 4, we're looking at the blue sides, 4 over 15, and then looking at the green ones, x over 6. So now we can cross multiply, 15 times x and 4 times 6. So 15 times x is just 15x. 6 times 4 is 24. So all we have to do is get rid of this multiplication by dividing. We're going to divide both sides by 15. 24 divided by 15 gives me a nice 1.6. Which clearly this picture is not to scale because this side is 6 and this side is 15. They look almost identical. So this one should be smaller than 4 because this side is smaller than 15. So 1.6, if we wanted to put feet on there, that would be a good answer, and inches on the first one. Alright, we have one more word problem that we're going to solve here. It says a person who is 6 feet tall stands next to a tree and casts a shadow that is 2 feet long. At the same time, the shadow of the tree is 6 feet long. How tall is the tree? So we got a lot going on here. First thing it says to do is draw a picture. That's going to help us a lot. So I'm going to draw a tree and a human, right? A person. So here's my tree. Oh, that's not a tree. My tree. There's my tree and my person. I'm really good at drawing stick people, so there's my person. The person is 6 feet tall. So from here to here is 6 feet. That person is standing next to a tree that tree casts a shadow that is 2 feet long. So we don't know the height of the tree right now, but we know the shadow that it casts is 2 feet long. Oh, I'm sorry. Hold on. Let's go back. If I read this carefully, it says a person who is 6 feet tall is just standing next to the tree. That person, they're still talking about the person, casts a shadow that is 2 feet long. So their shadow from maybe the sun's up here, this shadow of this person is 2 feet. At the same time, the shadow of the tree is 6 feet long. So the tree casts a longer shadow that is 6 feet long from the sun. Okay? There's the shadow of the tree. They want to know how tall is the tree. So we're going to set up a proportion. I'm going to go from the human to the tree when I write my ratios. First, I'm going to look at the height. The height here is 6. The height of the tree is x. So when I write that, the human is 6 feet tall. The tree we don't know. And then looking at their shadows from human to tree, 2 to 6. 2 over 6. There are other ways to set up this proportion as well, but you need to follow the same pattern. Human tree, or like shadow height, when you write your proportions. So we're going to cross multiply. 2 times x is 2x. 6 times 6 is 36. Hopefully that's one you know. And then the opposite of multiplying by 2 is dividing by 2. So 36 divided by 2 should give you 18. 18 feet tall. Does that make sense? Could the height of that tree be 18 feet tall? And that is correct. All right. Your homework is to practice writing proportions using similar figures. Make sure you are following the same pattern. For example, this one, we need to find x, so that goes with 14 on this side. So when you write your proportion, go from the small to the large or something like that, and then use any one of the other sides where you have both side lengths. We're not going to use this top side because we don't even know what this side length is. So we're not going to use that. So set up your proportion. For example, this one we could write 14 over x from the small to the large rectangle, and then 12 over 168 on this side to this side.